All right. Hello, everybody, and good morning, good afternoon, and good evening, and good night in some places of the world. And I'm happy to welcome you to the second session of the training for the policymakers that will be dedicated to efforts in quantum technologies beyond European Union as a natural continuation of the first session, which introduced European Union ecosystem in quantum technologies. And my name is Oksana Mishina, and I work in CNR. This is the National Research Council in Italy. And I would like to present you also the team that helps me to run and prepare this wonderful training. And this team consists of Costanza Toninelli, who is an experimental professor at National Institute of Optics that belongs to CNR. And me, I'm a theoretical physicist, but at the moment I work for coordination or support for quantum technology, Flagship. And Diana Tartaglia, who is a Master of Science in Physics and also in Science Communication, and is now doing a PhD in quantum technology. We are really happy that this training is taking place because it was somehow desired by the policymakers, and we made it in connection with policymakers. And we would like to provide you knowledge about the situation and help you to take informed decisions and cooperate with peers from other countries, and also talk with fellow scientists and researchers. Just a little bit about you. So most of you are from the government, and a big part from academia and the research. Few participants are also from the industry, and some people are covering more than one areas like government and industry, for example. So there is a fair part of people who would like to know a little bit more details of quantum technology because they were a little bit far from the field, but majority of you is well updated and keep regularly updating themselves. And we are happy to have you here, which means that our update is the freshest at the moment. And we have 18 countries, participants from 18 countries, and also from Japan and US beyond the European Union. And with this, there is one more statistics, which will be more updated because this was exactly the area one. So here is also with the highlights that Japan and Netherlands is most actively participating in the seminar. And let me introduce you our dear colleague from Coordination Action and our moderator for today, Caroline Sevin, who is has a Master of Science degree in International Relationships and with a focus on defense and security. She is a coordinator for the group that is involved in international cooperation for the Quantum Flagship coordination project, and she identifies mutually beneficial opportunities for the European Union and Canada, Japan, and United States. Caroline, I welcome you on stage, and
thank you
for
the introduction.
Moderation time, and looking forward to see the overview from you about the world current situation in quantum technology.
Sure. Hi, everyone. Nice to meet you all. I will just share my screen with I will do a short presentation on efforts beyond EU, a really short overview. Just a moment. Just here. Yeah. So the point of the presentation, unfortunately, I cannot be fully complete because we are short of on time. So what I want to show you here is that there is multiple quantum strategies worldwide. I will share a map just after with some key countries, of course, that putting more effort than other, but more or less we can see that the entire world is looking at quantum and putting public money in it. And we will see also that there's a whole quantum industry that is going on, and with some interaction between them and between different countries. On a governmental level, we can see also that there is numerous bilateral or multilateral agreements that are being signed or was signed before, which mean that governments are looking for complementarities and cooperation. My personal opinion is that despite all the willingness and the effort and the money you can put in quantum, it is really necessary to have some partnership, because one country cannot do everything. And this is why the Quantum Flagship is involved in international cooperation through two actions, as Oksana said. So we have a CSA called InCoQFlag that is really focused on Canada, Japan, and US, and also under the 𝐀𝐠𝐞𝐬𝐚, that's the Quantum Flagship CSA. We are working at a work package on bilateral meetings and analysis for the Commission. Just as I was saying at the beginning, you can see through this map that was released by Eureka on January or February, I think, that the world is looking at quantum, and the effort estimated from, I would say, I think this map goes from the early 2010s to now. The effort is $36 billion. What I try to highlight here is that the main efforts come from North America, Europe, and the Pacific region. It seems obvious that Latin America and Africa are less, less involved, but maybe it's a matter of time. What's interesting here is when we look at effort per region, we see that Europe invests a lot in quantum, especially because there is this I would say this specificity of Europe, that there is a funding at the European level with 1.1 billion, and also on national level, which leads the total budget to $12 billion. On the other hand, the Pacific region is really active, but there is some kind of a bias here that, according to this map, China provide $15 billion, which is actually quite overrated according to different studies. And from what I was able to read, it seemed that China is more close to $3 billion from this period. Nevertheless, it's quite huge for only one country. And the question that this might raise is for how long countries will be involved in quantum and will inject money in. It's quite a lot, and we can see that from Eureka map, every year the amount is increasing. If we are looking only to 23, there are 3 national strategies that have been released, 3 major ones. In January, it was Canada. This strategy was actually quite expected since 21, but it was released this year. Then India, that was already invested in quantum, but without a clear national strategy. And then finally, Australia also released one few weeks ago in May. So just for this year, for now, there are already 3 countries. Now, if we're looking out of the government part and more to investment, it's interesting to see that we have the same effect on private funding, that only for 2023, we estimate that the total investment from the private sector is $900 million only from January to now, which is really huge, even compared to the other years. And we can see that there is some huge amounts, like Sandbox in US with 500 million, or in Europe with Pascal with 100 million. And for me, this really illustrates the attractivity of quantum industry and the capacity of those startups to potentially scale up. What we can imagine that not all those startups will become major industry. There will probably be some selection, but it provides a good picture. And also we see that among those investments, it comes from Europe, but also Asia, North America, Australia. It comes from everywhere. The only thing I wanted to highlight also is that in this table, China is only represented one time. Again, I think it's a biased point of view. We may not have all information. A focus I wanted also to do was on the interest of international organizations in quantum. This is only a sample of what international organizations are doing, but we can see that some of them are at least creating working groups on quantum, which is the case for the ITU or G7, but also a real council with the future of quantum economy at the World Economic Forum. And last but not least, NATO is also involved in quantum, which highlight the potential dual use of the technology. I won't go deeper on those initiatives because it will take too much time, but it's interesting to see that we saw that governments are investing, then industry, but also international organization, meaning that quantum is really, I would say, an industry in that we want to monitor at every level. And finally, I wanted to highlight also something that really is for me quite interesting regarding international cooperation, is the AUKUS Pact that was signed in September 21. So probably most of you know that the AUKUS Pact was signed for a submarine purposes at first. So this is pillar 1 of this pact, but actually there is a pillar 2 around deep tech technologies, and I would say a sub-pact on quantum called the AUKUS Quantum Arrangement. And there is currently, it's ongoing discussion and an arrangement between Australia, UK, and US to have a trilateral cooperation on dual use quantum technologies. And I think it's really something to look out for and something that might be really interesting. So I try to make as short as possible. And as I told you at the beginning, it was a really fast and short overview. If you have any question, I will be happy to answer probably at the end of this training. Thank you.
Thank you very much, Caroline. This was an awesome presentation, and we have got the first high-intensity input about the worldwide situation in quantum technology. And now I would like to invite our first speaker, Kenji Ohmori. He's from Japan, and he's a chair of the Committee for Quantum Science and Technology Policy, MEXT, in Japan. And while Kenji is coming to the stage and turning on his camera, and he's here, welcome Kenji, I would like to share with you that Kenji is a chair professor at the Institute of Molecular Science, National Institute of Natural Science in Japan. And after receiving his PhD from the University of Tokyo in '92, He was a research associate and an associate professor at Tokyo University. In 2003, he was appointed a full professor at this institute. So Professor Ohmori is currently leading a large-scale and a long-term national project on the development of ultra-fast quantum simulators and quantum computers that will range from 2019 until 2030, long-term wise. And it is generously supported by the priority by the MEXT and the Cabinet Office of the Government of Japan, and expected as one of the top runners in the quantum technologies. So I'm honored and I'm looking forward for the presentation that Kenji has prepared to us. Please.
All right. Can you see the presentation, Oksana?
Yes, it's
All right.
well.
All right. Okay. So thank you. So many thanks for kind introduction. This is Kenji Ohmori. I'm serving as the chair of the Committee for Quantum Science and Technology Policy of the Government of Japan. And today I will talk about Japan's policy on quantum technology and innovation. And so far, we have issued a couple of official policy documents for quantum technology and innovation. And 2020, quantum technology and innovation strategy, where we said 4 key areas of quantum technology as well as the quantum technology innovation hubs. And in 2022, a vision of quantum future society, where we elaborated the strategy towards possible social transformation to be realized by quantum technology. And this year, 2023, a strategy of quantum future industry development, where we elaborated the strategy for practical applications and industrialization of quantum technology. And in these political efforts, we set 3 ambitious goals by 2030 as the Japanese government, and 10 million quantum technology users in Japan, and $350 billion in the production value from quantum technology, and fostering quantum unicorn companies to create future markets. And actually, we have 3 basic concepts that underlie the developments of those 3 policy documents. Quantum technology involved in our socio-economic system, hybridized with classical technologies and utilized to create opportunities for the industry in Japan to grow and to solve social problems. Number 2, promotion of the utilization of cutting-edge quantum technology through the development of test beds for quantum computing, communication, and so on. And finally, creation and activation of new industry with quantum technologies by supporting and the creation of startups and strengthening quantum technology hubs, fostering and attracting high-level quantum human resources, which should lead to strong quantum technology workforce and IP protection, standardization, international and industry academia collaboration, outreach, and so on. So this is a bit more explicit direction on the industrial development of quantum technology to achieve that 2030 goal that I mentioned in the previous slide. And this direction is summarized in these 3 perspectives. Number 1, collaboration. The collaboration and co-creation between quantum technology and diverse industries such as material, chemistry, health, medical care, town planning, manufacture, logistics, transport, environment, energy, AI, telecommunication, and electronics, semiconductors. And also industry, academia, government collaboration, and global collaboration and expansion. And number 2 is accessibility. This is the realization of an environment where non-expert industry people can easily access and utilize quantum technologies. And incubation by proactive support for the creation and growth of startups and new quantum businesses. And we hope that three perspectives will make quantum technology practical, useful, and industrialized. To implement these policies mentioned so far, Japanese government is running various quantum technology programs and making the relevant investments exemplified by these major ones: a moonshot research and development program. Since 2020, there are actually 9 different goals ranging from medical science, environmental science, and to social sciences. And among these 9 different goals, there is a goal 6 for quantum technology, named realization of a fault-tolerant universal quantum computer that will revolutionize economy, industry, and security by 2050. And actually, my project is selected as one of the projects in this category. And here we invest $1 billion for 5 years for all these 9 different goals. And Quantum Leap Flagship program since 2018, and this covers a wide range of quantum technologies ranging from quantum computing, simulation, sensing, biology, software, education, and so on. And here also my project is selected as one of the basic foundation research. And here we invested $30 million for this fiscal year, 2023. And Cross Ministerial Strategic Innovation Promotion Program named SIP since this year, 2023, for quantum technology, named Promotion of Quantum Technology Applications to Social Problems by the development of test-based human resources, startups, and so on. And here we invest $18 million for this fiscal year, 2023. And also to implement our policies, we set the quantum technology innovation hubs for various targets, including quantum computing and quantum software, quantum information security, and quantum industry development, quantum materials, quantum sensors, and so on. And we set them not only in big cities such as Tokyo, Nagoya, Osaka, but also in local areas as Tohoku and Okinawa. So this QIH is all Japan organization and still developing. And with this strategy, we aim at 2030 goals. Once again, 10 million quantum technology users in Japan, and $350 billion in the production value from quantum technology, and fostering quantum unicorn companies to create future markets. So that's it, and thank you for your attention.
Many thanks, Kenji. This was a very, very insightful and interesting short presentation, and I greatly appreciate you for this input. And we will leave all the questions that will maturate to appear in question and answer section and answer them after our last panelist, Gretchen Campbel, who I would like to invite on stage now, will present the summary about the US. And I would also like to say a few words about Gretchen, that we are very honored to have here, and that she is known for her groundbreaking contributions to the field of atomic and optical physics. And she currently holds the position of Deputy Director for the National Quantum Coordination Office at the White House Office of Science and Technology Policy. In this role, she plays a crucial part in the coordinating national information science, quantum information science, and programs across the federal government. And currently, she is also a coordinator and a group leader in the laser cooling and trapping group in the quantum measurement division and in MEXT. So Gretchen, this is a big honor for us to have you here, and we are looking forward to know more about United States development in quantum.
Great, thanks so much. And Anna, do you mind sharing my slides? Awesome, great, thank you. Yeah, so I said, my name is Gretchen Campbell, and I'm the Deputy Director of the National Quantum Coordination Office. So the National Quantum Coordination Office lives within the Office of Science and Technology Policy. And I am on detail from NIST, where I'm an experimental quantum scientist by training. So we're actually a small office. There's only 4 of us in the coordination office, but one of the sort of features of our office is that we are all practicing quantum scientists that are detailed from other federal agencies working within quantum science. Do you mind advancing? Great, thank you. How do we coordinate? So as I said, we're the National Quantum Coordination Office, and we actually came into existence in 2018. Our office was legislated by the National Quantum Initiative, which was an act passed by Congress in 2018. And the role of our office is to coordinate quantum science across the federal agencies. So how do we do that? Well, one is that the National Science and Technology Council has 2 subcommittees that are focused on quantum information science, the SCQIS, and then a second committee, which is focused on the economic and security implications of quantum science. Now this was actually legislated as part of the NQI Act, and then updated as part of another Defense Authorization Act, sort of created these 2 committees and also our office. There's also a Presidential Advisory Committee, the NQI Advisory Committee, that actually just recently published its first report, sort of recommending updates to the NQI. And as part of the NQI Act, NIST helped to create a quantum economic development consortium that I'll talk about a little bit later. Now, the original NQI Act actually only had authorizations for 3 agencies, NIST, NSF, and the DOE. And those agencies plus the DOD are co-chairs of these 2 subcommittees. Next slide. And one of the reasons one needs coordination in a coordination office is because there are so many federal agencies within the US quantum ecosystem that are participating in quantum. So as I said, we have sort of 2 subcommittees of the NSTC focused on quantum information science. And through those subcommittees and a number of interagency working groups that come from those subcommittees, we have 23 federal agencies that we're coordinating across through these subcommittees and interagencies working groups. Now, all of these agencies have different mission spaces, and their role in quantum is different. We have both civilian and defense agencies. Some of these agencies are actually have labs that are doing fundamental research in quantum. Some of them are funding agencies that are funding research in quantum, and some of them are end users looking at quantum for particular applications down the road. So the job of our office, is to coordinate amongst these agencies. And also we run some events to bring people together and leverage what's going on in different agencies and help identify gaps and figure out ways we can leverage each other's resources to accelerate quantum science in the US. Great, next slide. So along with this legislation that created these subcommittees and coordination, in 2018, the US also initially published its first national strategy on quantum information science. And in that strategy, which you can find on quantum.gov, it sort of identified 6 major pillars. One, of course, to take a science-first approach to quantum, make sure we're providing key infrastructure. It identified the importance of building and growing a diverse and quantum-capable workforce. Of course, helping to nurture quantum industry, and of course, the importance of balancing economic and national security while also promoting the science, and of course, developing international collaboration and cooperation. Now, as I said, I'm an experimental physicist by training, and I would argue that quantum has always been very international, and the fact that we are here today is because of the international cooperation and collaborations that have occurred over many decades in quantum science. Now, this initial strategy was published in 2018, but the strategy has continued to evolve and expand. The subcommittees and their working groups have put out a number of strategy documents to sort of develop and advance this strategy. Another important thing is we actually put out an annual report every year, which you can also find on quantum.gov, which talks about the programs and research going on in each of these agencies, and also has a little bit of information about spending. And you can see that essentially since the NQI Act was passed, spending in quantum has roughly doubled in the US federal agencies. Next slide. So as I said, the initial strategy document had sort of 6 main areas, but these days we really much sort of put it into 3 main pillars. And the US strategy right now for quantum is essentially getting the science right, enhancing competitiveness, and enabling people. So how do we get the science right? So as I said, the initial NQI Act actually had explicit authorizations for 3 agencies, NSF, DOE, and NIST. And for NSF and DOE, the NQI authorized the creation of 10 new research centers focused on quantum information science, 5 which are funded by the National Science Foundation and 5 which are funded by the Department of Energy. So those centers have all been stood up in the last few years and involves a large number of collaborations between different universities and DOE labs, some industry collaboration, and are sort of spread out across the United States. So for the NSF institutes, we're authorized to spend up to $5 million a year, and the DOE center is up to $25 million a year. And essentially, these centers are focusing on sort of, fundamental science, while also trying to start to collaborate with industry and others to advance and accelerate quantum as fast as possible. Next slide. So I said also, another pillar is enabling competitiveness, and part of the way we do that is through engaging in industry. So our office has run sort of a summit on quantum industry and society, where we brought together industry representatives to sort of highlight ways we could partner with industries to enable and support sort of the emerging quantum market, and also think about things like how do we protect and grow the supply chain for quantum, given that, this is still a very nascent field. The third agency that was given an authorization as part of the National Quantum Initiative was NIST. And essentially NIST was authorized to facilitate the creation of an industry-led consortium. And that is the Quantum Economic Development Consortium, which we already saw a little bit from Caroline's introduction. And essentially this is an industry-led consortium, which now includes over 170 companies and also includes members from a number of countries. I think it's up to 38 countries at this point. And essentially the QEDC works together to, to also push industry forward. And that consortium has a number of technical advisory committees that are also looking at different things within the quantum ecosystem, such as workforce, end cases, supply chain, and things like that. Next slide. And finally, international cooperation, which is important both for continuing, competitiveness, but also for enabling people, right? So, the U.S. does, international cooperation is one of our pillars. And as part of that, as we've already heard, we have, signed a number of bilateral quantum cooperation statements over the last few years with a number of countries. We are also participating in multilateral dialogues. In May of 2022, our office actually hosted a meeting bringing together representatives from 12 nations to start talking about, how we can work together to accelerate quantum information science. Now, in addition, many agencies within the quantum ecosystem in the U.S., particularly the NSF, has been providing sort of dear colleague letters or other funding for international cooperation in quantum. So on the NSF side, this tends to be supplemental funding to NSF grantees to allow them to pay for travel and things like that for international cooperation. But many other agencies within the US, particularly DoD agencies, actually directly fund quantum research going on in other countries. So international cooperation has taken sort of many forms, both through these sort of high-level cooperation statements, but then through funding to help encourage grassroots level cooperation to continue and grow between US researchers and researchers in like-minded nations. Next slide. And finally, what are some of the things that have come out of these multilateral engagements? And, I know we're short on time, so I will keep this short, but I wanted to highlight the Entanglement Exchange, which is something which was launched back in November. And this is sort of an attempt of sort of the initial 12 countries that came together in this multilateral dialogue to figure out a way to exchange and highlight opportunities for international collaboration. So there's now this entanglement exchange that has 13 countries so far, and I expect it will grow, where essentially we have a central repository so that people can come and see what opportunities exist for international researcher exchange. And in addition to the entanglement exchange within the US, of course, we're also doing a number of things related to workforce development and trying to grow and expand the quantum workforce. And with that, thank you for your time, and I'll stop here so that we have lots of time for questions.